Welcome to aminacademy.com. In chemistry, let us discuss about classification and properties of covalent bond structure. Here, first for that, electronegativity and bond types. When you examine electronegativity differences between elements, we may notice a connection between electronegativity differences, the polarity of a bond, and the strength. That means there is a direct connection between electronegativity and the bond types. The greater difference between the electronegativity values of two elements joined by bond, the greater the polarity of the bond. That greater electronegativity is a greater values of polarity of the bond. Look at this figure here. In addition, a greater electronegativity differences tends to associated with a stronger bonds. Here the greater electronegativity goes like, then here for the pure non-polar covalent bond, this structure is like, polar covalent bond is structure like, and ionic bonds is like. Electronegativity and bond types. Further explanation, we may notice that when sodium and chlorine react, an electron is removed from sodium and transferred to chlorine to the form of sodium ion and chlorine ions. These ions form an ionic bond, we know already. However, when hydrogen and oxygen gas react their atoms from a polar covalent bond by sharing electrons. We know that covalent bond is by sharing an electron from adjacent elements. Now, bonds can be classified by bond character also. That means properties of substance depends on a bond type. We may notice that in general rule that can be used to predict the type of bond that forms. If the difference in electronegativity is between 0 to 5 or 0 to 4, the bond is probably non-polar covalent bond. If the difference in electronegativity is between 0.5 to 2.1, the bond is considered as polar covalent. We can write it this one here. Electronegativity 0 to 0.5. This bond is non-polar. Then 0.5 to 2.1 is a polar. Then larger than 2.1 is an ionic bond. When the bond is usually ionic, if it is electronegativity is more than 2.1. If another general rule states that covalent bonds tends to form between non-metals, while a non-metal and metal will form an ionic bond. We may understand how electronegativity differences provide information about bond character. The electronegativity differences between, for example, calcium and oxygen is 2.4, then they also form an ionic bond. However, a larger electronegativity differences between sodium and fluorine means that the bond between them has a higher percentage of ionic character. Now, properties of substances depends on a bond type. Further discussion. The type of bond that forms determines the physical and chemical properties of the substances. For example, metals such as potassium are very good electric conductors because it is having free electrons, plenty of free electrons in outermost orbits. Electric conductors in the solid state. In the solid state, these are good electric conductors. This property is the result of metallic bonding. Metallic bonds are the result of the attraction between the electrons in the outermost energy level of the each metal atom and all of other atom in the solid metal. The metal atoms are held in the solid because all of the valence electrons are attracted to all of the atoms in the solid. These valence electrons can move easily from one atom to another. That is why metals are good conductors of electricity. They are free to roam around in the solid and then conduct an electricity. In ionic substances, the overall attraction between all the cation and the anion is very strong. Ionic compounds such as potassium chloride are made up of the potassium and chlorine ions. Each ion is held into the place by many oppositively charged neighbors. So the forces, that ionic bonds that hold them together, are very strong and hard to break. Because bonds are strong, so it's hard to break. In further discussion, we'll do in next videos. We have done. Please subscribe our YouTube channel.